In iOS XR, we do not have the concept of route maps. Here, iOS XR introduces a new policy defining language called the Route Policy Language, RPL. RPL provides a lot of features which are not available with route maps. It helps in scalability, it helps in modularity, means you can reuse the portion of the configs that you have already created somewhere else or before. Parameterization, where you can define route policy with a parameter as a function, or you can call that route policy in another route policy. So it's kind of a hierarchical structure as well, but also you're using the concept of parameterization like you do use in programming languages. You can define explicit logic, and you can also define where you want to have those route policies attached. So you have various attach points for the route policy. There are different actions on the route policies in iOS XR. Pass. In this, you are allowing the prefix if it's not getting dropped later on using some filtering mechanism. If you set pass, you grant a ticket to defeat the default drop on the route policy. If you have configured pass, the execution continues after the pass statement. With the set statement, you can set the values for the prefix and also allow the prefix at the same time. This set statement gives you a level grant for the ticket, and the execution still continues after the pass statement. Drop. The prefix gets discarded, and it's an explicit drop, means that the policy execution stops after that. It's called an implicit drop as well. Done. With the done statement, you stop processing the route policy and accept the prefix. It's important to note that there's implicit drop at the end of RPL processing. So with various statements, you can defeat this implicit drop mechanism. There are various actions and operations that you can perform with RPL. You can define various BGP attributes such as next hop, wait, local preference, MED, origin, ASPath, community, extended community, and route distinguisher value. From the RPL attributes perspective, you can specify the source, destination, route type. Rib has a route. It's kind of a verification if the routing table has the route present in it or not. Traffic index, dampening, label, and tag. And you can have different RPL operations based on the match criteria or attributes that you have used. You can have a pass or drop, suppress the route, unsuppress the route. You can set the length, unique length, set operation, apply, if and then, else, else if, and or not, equals, and so on and so forth. These are some of the operations which are similar to various programming languages you might have come across during the course of learning computer science, which is not available with route maps in the present day. Let's now have a look at some of these operations. If then and else if. Using the if then and else if statement provides you with a set of condition and actions. If you match a criteria, you can go to the then part. If the criteria doesn't match, you can move to the else if, and so on and so forth. This is similar to how a if and else if statement works in programming languages. Here's an example. If ASPath is in ASPath set 1, then drop. If not, you can perform another action. Similarly in second entry, if the med value is equal to 150, you can set the local preference to a particular value. If it's not 150 and it's equal to 200, you can set the local preference to 200. If it doesn't matches any of these two above criteria, you can set the local preference to 0. Nested ifs. You can also use if statements within another if statement. That means if the first criteria matches, then you go into that section and perform another if. So if the community matches 12:34 or 56:78, then go into this section and say if the MED is also equals to 8. If it is equals to 8, then drop. And after it has performed this action, you can set the local preference to 100. Remember, if a prefix matches this criteria and you have specified the drop statement, the processing of the RPL stops. So the set's local preference statement will not get executed. If any of the prefix which is matching the community values and it's not falling under the criteria of the nested if statement, then it will set the local preference to value 100. The Boolean logical operators can be used while applying RPL policies. It gives you more flexibility to perform multiple match criterias for a single prefix. So say for you have criteria saying if not match condition 1 and match condition 2. That means the prefix is not part of the match condition 1, but it is part of the match condition 2. Then there's also an OR statement after the first two conditions, or match condition 3. Means it says that the prefix is not in the match condition 1, but are in match condition 2. However, any prefix in match condition 3 are allowed regardless of match condition 1 or 2. That means if the prefix is matching or not matching in 1 or 2, you can still have a match in the match condition 3. This makes it easier for understanding the whole match operation for a prefix or within the route policy. These Boolean operations give you the flexibility to create compound operations on the Boolean operators using the Boolean operators. Prefix set. A prefix set holds IPv4 prefix match specifications, each of which has 4 parts. So you can have an address, a mask length, a minimum matching length, and a maximum matching length. So in this example, you can see you have a prefix 10.0.1.1, which is just an IP address. Then you have a mask length as well for another prefix 10.0.2.0/24. You can use the less than and greater than operations to define the minimum and maximum length for matching prefixes in the prefix set. Community set. A community set holds community values for matching against the BGP community attribute. You can define a multiple list of community values within the community set. You do not have to define different sets or community list for matching different community values. So example here, you can notice that the community set named community allowed has the matching entries 12:34, 12:56, and internet. Well, remember, internet is a predefined community value. The community values are expressed in the notation of AA:NN, which is divided into two 16-bit values separated by a colon. An ASPath set comprises of match operations on the ASPath attribute. You can form a list of ASPaths within the ASPath set, and then you can use that list to perform match operations in the if and else statements. Remember that the regular expression used under the ASPath set is compatible with the iOS regular expression used while defining ASPath access list. Let's now have a look at the various BGP ASPath conditions. In Cisco iOS, for matching the local routes, you use permit, caret, and $sign. With RPL, it's more understandable and readable. You can simply define saying if ASPath is local, and you simply match the local routes. Second is only routes from a particular neighbor AS number, and you say in iOS you define it as permit, caret sign, AS number, and underscore. In RPL, we have the simple statement like if ASPath neighbor is from the AS number. You can notice that how simple it is to define the policies or define the logic in RPL than with Cisco iOS or even Nexus OS devices. If you walk through the whole list, you will notice that all those entries in the RPL logic are self-explanatory itself. You do not have to go and define separate ACL policies and also remember the different regular expressions which you had to remember in Cisco iOS devices. Prefix list functionality in RPL. Notice that in iOS, we had to define separate prefix list to match the criteria in route maps. In RPL, you don't really have to do that. You can have the same prefix list functionality in the matching if statement itself. For example, in RPL, you can simply define if the destination falls under the list 192.168.0.0/16, which and greater than equals to 16. And with the criteria, the destination is not in 192.168.1.1. You're also performing an logical AND operation, and you are performing a match criteria based on the prefix list. But you don't really have to explicitly define the prefix list in RPL. These are some of the functionality and features which are available with RPL but not available with route maps or any other tools. The RPL functionality can give you more flexibility in defining routing policies, which makes it more scalable in XR than on any other devices.